Here the robot is trying to move to the starting position. It is trying to find an orientation configuration, but I think we're iterating over too many random TOE matrices because there's 2 degrees of freedom there. So we may want to try constraining it to only 1 variable instead of 2. Okay, finally got there. 206 iterations. So it's going to be moving directly above to 00400. Now speaking of getting the random configuration, giving a XYZ coordinate or random orientation, the benefit of doing a lot of iterations is that before, when I only changed one of them randomly, it couldn't get there. But now it can, even though it takes like 20 seconds to calculate. So now that it's gone to the start position of 00400, it is currently getting configuration for the goal of 200, 200, 222.25. And in this case, it takes about 15 to 20 seconds just to get the configurations. And now it's trying to plan the path to there. The previous one only took 206 iterations, but in this case, it could take anywhere up to 10,000 and it might not even find the path. It's kind of been hit or miss for us sometimes with the RRT. It doesn't look like it's going to find a path here. So I think it's going to just get stuck. But in a previous iteration, it did get to 200, 200, 222. I wonder if something I've noticed is that each time we either have only like 100 or 200 iterations to find the path, or it doesn't even get there after 10,000, which leads me to think that maybe it's the robot, like maybe the tree grows so dense that it kind of hits a local minimum, and maybe that's why we need to grow the RRT from both sides. Another approach is, instead of adding the constraint that the robot has to be within some particular distance to the goal, let's try and remove that constraint to see if it does any better.